Ask My Instructor 4.4.23. You are designing a rectangular poster to contain 48 square inches of printing with a 3-inch margin at the top and bottom and a 1-inch margin at each side. What height and width should the poster be to minimize the amount of paper used? Let W be the width of the printed part. Let H be the height of the printed part. Then 48 square inches of printing means that W times H is equal to 48. Also, the 3-inch margin at the top and the bottom means that the poster height is H plus 6. The 1-inch margin at each side means the poster width is W plus 2. And the total poster area is W plus 2, that's the total poster width, times H plus 6, that is the total poster height. What height, H plus 6, and width, W plus 2, should the poster be to minimize the amount of paper used? The goal is to minimize the area W plus 2 times H plus 6, subject to the constraint W times H equals 48. We use the constraint to write the objective function in terms of one variable. You can either write H in terms of W or W in terms of H. It really doesn't matter. I'm doing it this way. By doing it this way, my objective function ends up being written in terms of W. So my total area of the poster is now a function of the width of the printed area. And we want to minimize that total area of the poster. To find the critical points of our function, we're going to want to take the derivative. And rather than using the product rule, rather than taking the derivative right away and using the product rule, I prefer to go ahead and find the product. You don't need to do it that way, but that's just the way I want to do. And so I just go ahead and FOIL it out, and then I combine like terms. Notice that I'm writing 96 over W. I'm writing it as 96 times W to the negative 1. And I do that because it makes taking the derivative a little bit easier. Go ahead and take the derivative now. The derivative does not exist when the width of the printed area is 0, but W equals 0, you can see, is not in the domain of our function anyway. So that's really not a point of interest to us. So we next look to see where the derivative is equal to 0. I set my derivative equal to 0. And then I go about solving for W. It's a pretty straightforward process. I take 96 over W squared, take it over to the right-hand side. And then I multiply both sides by W squared, divide both sides by 6, and I get W squared equals 16. And I'm only interested in the positive square root because we're talking about the width of the printed area. So W equals 4 is going to minimize my poster area, and the poster will have a total width of 6 and total height of 18. A rectangular poster with 48 square inches of printing with a 3-inch margin at the top and bottom and a 1-inch margin at each side has a minimum area when its width is 6 inches and its height is 18 inches. You can see that the original poster I drew is not proportioned correctly. And that's helpful because it tells me that I was not swayed by my own picture. So 6 by 18 will do it, and you have a great day.